Just a few more introductory remarks on Jupiter then. As we sort of discussed in the last video here, it has a very powerful magnetic field, because as you get sort of in these inner portions right here that get sort of deep under pressure here, there's a lot of metallic hydrogen in there that conducts electricity, and so that I get those charges swirling around in there. In terms of energy, it has sort of this factor of 1.67, and being over 1 means energy is still coming out, likely from when it formed. If you ever get down near Jupiter, and we've sent a space probe there, as I'll discuss in a subsequent video here, there's very fierce winds and lightning that you would encounter in there. You might expect that with all the winds and the gases blowing around is very much like a storm or whatnot on Earth here, and so you'd get some of these storm types effects in there. In some of the timing that you'd get, it has a 12-year orbit, so it's quite far from the sun, so that will be a small number, but then get this, it has only a 10-hour rotation. So in terms of rotating and speed and that sort of thing, the rotation around its axis like this is really something fast. 10 hours for this huge planet to rotate around once. In terms of size and compared to the Earth here, the circumference. So the circumference of a circle is the distance all the way around the circle. So if I got a nice thick line, sort of drew a line going all the way around the planet and all the way around. So if you travel all the way around like that, for Jupiter, it'd be something about 250,000 miles sort of plus. So in excess of 250,000 miles, that's sort of Jupiter's here. But of course on Earth here, it's something more like 24,000 miles. So see, traveling around Jupiter would be sort of a journey that's like 10 times that on the Earth and that sort of thing. In terms of another, one of its key properties here, its density. It has a very low density, relatively speaking, something like only 1,300 kilograms per cubic meter. And if you recall, when we were talking about the Earth and the moon formation and that sort of thing here, the Earth then has a density of something like 5,500 kilograms per cubic meter. So you can see that Jupiter is much, much, much less dense than the Earth. In terms of viewing it in the sky here, it is extremely bright because of all of those clouds and things. And the only thing it does not outshine then would be the moon and Venus. So Venus is still going to be brighter, but Jupiter is right there after those two. And these are all the clouds that you see here. All these wispy things that you see here are all clouds. And they should be all white, but there's chemical reactions going on with Jupiter that sort of make those colors happen. And like I said, as you go deep, deep, deep into Jupiter, like you take a cross-sectional cut like this, as you go deep, 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 this area here might be all gas still, but then as the gas pressure gets larger and larger, the gas sort of becomes a liquid in here, and sort of in the inner core, who knows what's in there, maybe something approaching a solid or maybe even solid, who knows. But with all that liquid spinning, that's sort of where the magnetic field would come from. And also, just a couple more facts about Jupiter here. Being so big like that, it has 75 moons, all to be discovered. The first 4 are usually the ones that we discussed. I'll give you some info on those in subsequent videos. And at the moment then, there is sort of your wrap-up introduction to some of the key facts about Jupiter. So it's really just a very, very different planet. Nothing like we've discussed, nothing like those interterrestrial planets. So we'll get on with a bit more of it in subsequent videos.